Like, subscribe, and hype the video. Also, leave a comment on any topics you want to hear about in the future. Okay, let's dive in. On the night of August 15, 1977, a radio telescope in Ohio recorded a signal from deep space so strange, so powerful, and so perfectly matched to what scientists had predicted an alien transmission might look like, that the astronomer reviewing the data circled it in red pen and wrote a single word in the margin: "Wow." Almost 50 years later, that signal has never been detected again. Nobody has ever definitively explained where it came from, and to this day it remains one of the closest things humanity has ever recorded to a genuine signal from another civilization. Today, we're walking through exactly what happened that night, what the signal actually looked like, and why scientists got so excited about it in the first place. And in our next episode, we're getting into every major theory for what it could have actually been, including one explanation that gained serious traction just a few years ago, and another that a lot of scientists still aren't fully satisfied with. Stick around for that one. But first, let's understand the night this whole mystery began. The signal was picked up by a radio telescope nicknamed Big Ear, operated by Ohio State University, as part of a long-running project specifically searching for signals from extraterrestrial intelligence, an effort that today falls under the broader umbrella known as SETI, the Search for Extraterrestrial Intelligence. Big Ear wasn't a small backyard setup. It was a massive fixed radio telescope built using two enormous reflective surfaces spanning hundreds of feet, designed to continuously scan strips of the sky as Earth's rotation carried different patches of stars past its field of view. Rather than physically pointing at one target and tracking it, Big Ear worked more like a stationary net, letting the sky slowly drift through its detection range as the planet turned underneath it. The project had been quietly scanning the sky for years by 1977, recording data onto large stacks of paper printouts that researchers would have to manually review afterward, looking for any signal that stood out from the ordinary background noise of the universe. Most of the time, that meant flipping through page after page of essentially nothing unusual at all. Like, subscribe, and hype the video. Because the night this changed, everything started out as a completely ordinary shift. On that night, the telescope's data was being recorded automatically, with nobody actively monitoring it in real time. A few days later, when astronomer Jerry Amon sat down to review the stacks of computer printouts, he came across a sequence of characters that immediately stood out from everything else on the page. Big Ear measured signal strength using a scale of numbers and letters, where higher numbers and letters represented stronger signals compared to the normal background noise. Most of the printouts from any given night showed low, unremarkable readings, 1s and 2s, the kind of faint static you'd expect from natural background radiation. But on this particular printout, one sequence read 6 E Q U J5. That string of characters represented an almost unheard-of climb in signal strength, peaking at a level around 30 times stronger than the normal background noise of deep space, before dropping back down just as sharply. Amon was so struck by what he was looking at that he circled the sequence directly on the printout and wrote "Wow" next to it in red pen, and that single handwritten note ended up giving the entire event its now famous name. Here's what made this signal genuinely remarkable, beyond just being unusually strong. The signal arrived at a very specific radio frequency, close to 1,420 megahertz, a frequency known among astronomers as the hydrogen line. This particular frequency matters enormously in the search for alien signals, because hydrogen is the most abundant element in the entire universe, and it naturally emits radio waves at this exact frequency as part of basic atomic physics. For decades, many SETI researchers had theorized that if an advanced civilization wanted to send a deliberate attention-grabbing signal across interstellar distances, this specific frequency would make logical sense as a kind of universal hello. A frequency that any other civilization capable of radio astronomy anywhere in the universe would almost certainly already be familiar with and actively monitoring, simply because of how fundamental hydrogen is to all chemistry and physics everywhere. In other words, the wow signal didn't just appear strong by random chance. It showed up almost exactly where theoretical predictions had suggested a deliberate alien signal might appear, if one ever did. That overlap between prediction and observation is a huge part of why this particular event captured so much scientific attention, and still does today. Like, subscribe, and hype the video. And let's get into exactly how long this signal actually lasted, because that detail matters too. The full duration of the wow signal was approximately 72 seconds. That specific number isn't arbitrary. It represents almost exactly the amount of time it would take for a single point in the sky to pass through Big Ear's fixed detection beam as Earth's rotation carried it across that patch of sky, which is the maximum possible observation window the telescope's design allowed for any one fixed location. This detail cuts both ways when it comes to interpreting the signal. On one hand, the fact that the signal's duration matched almost perfectly with the physical limits of how long Big Ear could observe any single point in the sky is exactly what you'd expect if the signal source was a real, distant, fixed point of origin, rather than something local, moving, or interfering with the telescope itself. On the other hand, it also means we genuinely don't know how long the signal might have actually continued beyond those 72 seconds, because the telescope's own rotation-based design physically couldn't keep watching that same point in the sky any longer, even if the source kept transmitting. In other words, the wow signal didn't end because whatever produced it stopped. It ended because Earth kept turning and Big Ear's beam moved on to a different patch of sky. In the decades since 1977, astronomers have pointed numerous radio telescopes back toward the same general region of sky the wow signal appeared to come from, located near the constellation Sagittarius, specifically hoping to detect a repeat of the signal. Despite multiple dedicated search efforts using various telescopes over the following decades, nobody has ever recorded the same signal again. This absence of a repeat detection is one of the most significant and most frustrating details surrounding the entire mystery. A signal that occurs exactly once and is never observed again despite repeated dedicated searches using increasingly sensitive equipment is much harder to confidently explain than a signal that repeats on a predictable schedule. It rules out several simpler explanations almost immediately, while leaving the door open to several much stranger ones. So that's the real story of the night the wow signal was recorded, a powerful, unexplained burst of radio energy, arriving almost exactly at the frequency scientists had predicted an alien civilization might use, lasting exactly as long as the telescope's design physically allowed it to be observed, and never once detected again, despite decades of dedicated searching since. In our next episode, we're getting into every major theory for what actually caused this signal, including the leading scientific explanation that gained serious traction a few years ago, the reason some astronomers still aren't fully convinced by it, and yes, the case some people still make that this really might have been a genuine signal from somewhere else entirely. Some of what we found while researching that episode might change how you think about this whole mystery. Like, subscribe, and hype the video so you don't miss part 2, and let me know in the comments what you think this signal actually was. I'll see you in the next one.